One of the problems that autonomous underwater vehicles have, they're all limited in the range that they can do. So this technology, a solar autonomous underwater vehicle, gets around that range by having a renewable energy source that allows it to be persistent out in the water. And so once you're able to have this extended duration and extended space coverage using this underwater vehicle, you can start to use it in kind of new modes. Autonomous underwater vehicle is a mobile platform. It's essentially having an autonomous captain on board. And we're marrying it with an autonomous sampler, like almost having a robotic deckhand on board. And so you bring those two together and you have the opportunity to go out and actually survey and map the ocean in an automatic sort of way. So we start thinking about extending that into full automation, and one of the ways we did that was start looking at Twitter as a way to incorporate a way to allow us to take the data that we're sensing in real time, because the vehicle has both real-time sensors on board and this automatic sampling technology. So it has the ability to both sense real time and then capture material and bring it back to the lab for further analysis.
And what we have here is a set of data from the SOV, giving us time, latitude, longitude, heading, altitude above the seafloor, and conductivity, temperature, and depth.
And so the idea is, could we use Twitter as a way to act as a handshake between the typical, mysterious machine and environmental world into what becomes something familiar and something we easily process in human language. Solar is our primary energy, so it comes to the surface, it essentially repowers itself. Once it's reached a certain level of power, it can go back down and starts to navigate underwater using an underwater compass. Comes back up to the surface, fixes its position again with GPS, recharges, and goes back down again.